Good afternoon. Good afternoon, Wanda. So my name is Professor M. Surnaran Reddy. Today our topic is vector differential calculus. In this chapter, we discuss del applied to vector point functions. In the previous class, we will discuss del applied to scalar point functions gives rise to divergent and now in this class del applied to vector point functions. So del applied to vector point functions gives rise to divergence of a point function, divergence and curl. First, we will define divergence of vector point function. If a bar of x comma y comma z be a vector point function continuously differentiable in a region R of the space, then the divergence of a bar is defined by del dot a bar. Del is defined by I dou by dou x plus j dou by dou y plus k dou by dou z dot a bar. Therefore, it can be written I dot dou a bar by dou x plus j dot dou a bar by dou y plus k dot dou a bar by dou z. Can be written sigma I dot dou a bar by dou x. So it is abbreviated as div a bar, and thus div a bar equals to del dot a bar equals to I dot dou a bar by dou x plus j dot dou a bar by dou y plus k dot dou a bar by dou z can be written in the short notation sigma I dot dou a bar by dou x. So if a bar equals to f1 I bar plus f2 j bar plus f3 k bar, then div a bar equals to del dot a bar equals to I dou by dou x plus j dou by dou y plus k dou by dou z dot f1I plus f2j plus f3k. Therefore, div f bar equals to del dot f bar equals to dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z. So it is simply dot product. But in general, it is not a dot product. Okay. So you can observe that f bar is vector point function. Divergence of a bar is a scalar quantity. The divergence of a vector point function is a scalar point function. The notation del dot a bar is not a scalar product in gender in the usual sense, since del dot a bar is not equals to a bar dot del, because left side is del dot a bar is a scalar quantity, whereas RHS f bar dot del equals to f1 dou by dou x plus f2 dou by dou y plus f3 dou by dou z is a scalar differential operator. Left side is scalar quantity, right side is scalar differential operator. So in general, these two will not the same. Now next, solenoidal vector. If a divergence of f bar equals to 0 everywhere in a region R, then f bar is called solenoidal vector point function and R is called a solenoidal field. So now the physical interpretation of divergence. Physical interpretation of divergence applied to a vector field is that it gives approximately the loss of the physical quantity at a given point for unit volume for unit time. So it is the meaning of divergence. So if we, for example, if v bar of x comma y comma z is a moving fluid at a particle at a point x y z, then the loss of the fluid per unit volume per unit time at the point is given by divergence of v bar. Thus, divergence gives a measure of outward flux per unit volume of the flow at x comma y comma z. If there is no loss, the fluid anywhere, then divergence of V bar equals to 0 and the fluid is said to be incompressible fluid. Next, if V bar represents an electric flux, div V bar is the amount of electric flux which diverges for unit volume in unit time. If V bar represents the heat flux, div V bar is the rate at which heat is using from the a unit a point for unit volume. So this is the divergence. Next we will go to curl. The del applied to vector point function, we will get another quantity, vector quantity, that is curl of a vector point function or curl of a vector field. The definition is if a bar of x comma y comma z be a vector point function continuously differentiable in the region R, then the curl of f bar is defined by del cross f bar equals to I dou by dou x plus j dou by dou y plus k dou by dou z cross f bar. That is equals to I cross dou f bar by dou x plus j cross dou f bar by dou y plus k cross dou f bar by dou z. That is equals to sigma I cross dou f bar by dou x. So it is abbreviated as curl f bar, curl f bar. Thus, curl f bar equals to del cross f bar equals to I cross dou f bar by dou x plus j cross dou f bar by dou y plus k cross dou f bar by dou z. That is equals to sigma I cross dou f bar by dou x. If f bar equals to f1i plus f2j plus f3k, then curl f bar equals to del cross f bar equals to I dou by dou x plus j dou by dou y plus k dou by dou z cross f1i plus f2j plus f3k is equals to determinant of the first row is ijk, second row dou by dou x, dou by dou y, dou by dou z, third row f1, f2, f3. Expanding the determinant with respect to first row, we will get curl f bar equals to del cross f bar equals to I into dou f3 by dou y minus dou f2 by dou z plus j into dou f1 by dou y dou z minus dou f3 by dou x plus k bar into dou f2 by dou x minus dou f1 by dou y. Therefore, curl f bar equals to del cross f bar equals to simply the 3 by 3 determinant. First row ijk, second row dou by dou x, dou by dou y, dou by dou z. Third row is f1, f2, f3. Expanding we will get. So here curl is always vector quantity. If the curl of a vector point function is a vector quantity or a vector function. Next, irrotational vector field. Let f bar of x comma y comma z be a vector point function if curl f bar equals to 0 bar at all points in the region R, then f bar is said to be an irrotational vector in R. The vector field R bar is called an irrotational vector field. Next, conservative conservative field. A vector field f bar is said to be conservative if there exists a scalar point function pi such that f bar equals to gradient of pi, grad pi. Conservative means there exists a scalar function pi such that f bar can be written gradient of scalar function. Then such scalar function is called potential. Okay, conservative field, the field can be written gradient of some scalar function. The function is called scalar potential. So we can observe the following. The first observation, in conservative vector field, f bar equals to grad pi. So we know del cross f bar equals to del cross del pi equals to 0. Del cross del pi equals to 0 bar, then f bar is rotational. Therefore, conservative means just simply it is a irrotational. If f bar is irrotational, it is conservative. In this case, f bar can be written gradient of some scalar function. So this scalar function is called scalar potential of f bar. Only irrotational vectors will have scalar potentials. Next, physical meaning of curl f bar. If f bar represents linear velocity of the point P of right body, then the rotation about a fixed axis, that is top, with constant angular velocity omega bar, then curl f at P equals to twice into angular velocity, that is curl f bar equals to 2 into omega bar. Therefore, omega bar equals to half of curl f bar. So, thus the angular velocity at any point is equals to half the curl of the linear velocity at that point of the body. Half of the curl equals to angular velocity. So, it is the physical meaning of curl f bar. If the body is not rotating, then W bar omega bar equals to 0 vector. Therefore, curl F bar equals to 0 bar. Then F bar is rotational. So we will explain some examples. So if R bar is the position vector, xi bar plus yj bar plus zk bar. So then find divergence of R bar equals to 3 and curl F bar equals to 0 bar. Just simply R bar equals to xi plus yj plus zk, then f1, f2, f3 will be xyz respectively. Divergence of R bar equals to del dot R bar equals to dou f1 by dou x, dou f2 by dou y plus dou f3 by dou z equals to 3. Curl R bar equals to del cross R bar equals to ijk, determinant of ijk, second row dou by dou x, dou by dou y, xyz. So expanding the determinant, we will get 0 I bar plus 0 j bar plus 0 k bar equals to 0 bar. So hence divergence of R bar is 3 and curl R bar is 0 vector. So it is treated as the result. If the position vector R bar is the given, then the divergence of R bar is 3 and curl R bar is equals to 0 vector. So it is used in vector identities. So find the divergence and curl of the vector v bar equals to xyz I bar plus 3x square yj bar plus xz square minus y square zk bar at the point 2 minus 1 1. So let v equals to v1i plus v2j plus v3k. Therefore, v1 equals to xyz, v2 equals to xy square x 3x square y, v3 equals to xz square minus y square z. So divergence of v bar equals to del dot v bar equals to dou v1 by dou x plus dou v2 by dou y plus dou v3 by dou z. That is equals to. So we will get yz plus 3x square plus 2xz minus y square. So at the point, substitute x equals to 2, y equals to 1 minus 1, z equals to 1. Therefore, div v bar at this point is 14. Similarly, calculating curl f bar. Del cross f bar, determinant of ijk, first row, second row dou by dou x, dou by dou y, dou by dou z, third row v1 v2 v3, expanding and then substituting the point. So we will get curl v bar equals to 2 I bar minus 3 j bar minus 14 k bar. Just expanding and then substituting the point, we will get the curl v bar at the point. Next example. Find the divergence of a bar curl a bar where a bar equals to gradient of x key plus y key plus z key minus 3xyz. First, calculating a bar. A bar equals to gradient of some scalar field. So just you can expanding I dou by dou x of j dou by dou y of plus k dou by dou z of function, scalar function. So we'll get a bar equals to I into 3x square minus 3yz plus j into 3y square minus 3xz plus k into 3z square minus 3xy. So that equals to f1I plus f2j plus f3k. Therefore, write f1 value, f2 value, f3 value, and then calculating divergence of f bar equals to del dot f bar equals to dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z. That equals to 6 times into x plus y plus z. So therefore, curl will be calculating curl f bar equals to del cross f bar equals to determinant of first row is ijk, second row dou by dou x, dou by dou y, dou by dou z. Write f1, f2, f3, and then expanding. So we will get 0 bar. Hence, divergence of f bar equals to 6 into x plus y plus z, and curl f bar equals to 0 bar. So next, another example. Show that a bar is irrotational and solenoidal. So to show the vector is irrotational, just curl a bar will be calculating. If curl a bar is 0 bar, then a bar is irrotational. Just calculating simply del cross a bar equals to curl a bar equals to 3 by 3 determinant ijk dou by dou x dou by dou y dou by dou z. Second row, third row, f1, f2, f3, and then expanding. So we will get 0 bar. So therefore a bar is irrotational. Divergence of a bar. Del cross a del dot a bar equals to just calculating. So it will be 0. So therefore a bar is a solenoidal. So thank you. Thank you.